Hello, this is Mrs. Ward, and I'm going to go over the second part of the take-home review packet for the final exam. This one will cover the matrices and systems. So number 17 says solve the system of linear equations using any method. So if it says any method and it's on multiple choice, then I am going to use my calculator all day long. I'm perfectly honest. My favorite way to do it on the calculator is the reduced row echelon form. So I'm going to put this in the matrix X, Y, and then my answer, X, Y, and then my answer. And then on my calculator, I'm going to do reduced row echelon form. So just to show you what that looks like, I am going to hit menu, 7, and then I'm going to go to number 5, which is, and I'll say that reduced row echelon form. I press the button that has my matrix. I'm going to go to 3 by 3. And when I look at my matrix that I just created, I'm actually 2 rows. So I'm going to go 2 rows. Oopsie, I want 2 rows, 3 columns. I'm going to hit OK. And then I'm going to put in those coefficients that I have. So I have 3, tab, 4, and then 9. And then the next equation is going to be -4, 1, and 12. And when I hit enter, I get those answers, which are not correct. Oh, my bad. And I would probably edit this, but I'm not going to. As if I got a fraction, I would go back and check it all the time. So I'm going to see that I forgot that negative sign on the 12. And then my answers are going to be that 3 and that 0. So my answers are 3, 0. If I have a chance to check it, I'm going to check it. If I don't, I'm not going to. So 18, let's say you don't like reduced row echelon. Maybe you're an inverse person. So you're going to do 1, 2, -4, 4. You're going to take the inverse of that, and you're going to multiply it by the answers, which are -4 and 7. And when you do that in your calculator, it gives you -3, -2, which means your x is -3, your y is -2. Any way that you can do it on your calculator is fine. 3 by 3, again, calculator all day long. So I am going to do, let's do the inverse for this one. So 5, -4, -3, -3, 5, x, y, there's no z. And so -5, -1, 1. I'm going to raise that to the -1 power of my calculator and multiply it by my answers. And if I'm having a good day, I am going to get 1, 0, 1 on my calculator. So my x is 1, my y is 0, my z is 1. Let's say 20, I didn't want to do it that way. Let's say 20, I decided to go back to reduced row echelon form. So I'm doing my augmented matrix. So 5, -2, 1, 8, -2, oh, no x, no x, no x, woohoo, no x. So 0, -2, 3, 16, -2, 4, 5, 12. I'm putting that in my calculator in reduced row echelon form. And when I do that, I'm going to get the identity matrix on this side. And then I'm going to have a column of my answers, which are going to be 0, 2, and 4. So my x is 0, my y is 2, my z is 4. And that's how I'm going to do it on my calculator. Now that's great and that's well, and for the multiple choice, that's what I'm going to do. But you know, on the free response, we are going to have one where you have to solve it by hand. So it's going to say use Gaussian or Gauss-Jordan elimination, which means I am going to do the entire reduced row echelon form. And if I'm freaking out, I'm not going to freak out. I'm going to look at my formula sheet, and I have this little guide right here with me sitting there whispering good vibes to me so I can do this. So I am going to write it as a matrix first. So 1, -3, -1, 3. I'm going to write it neater than I normally do. X, Y, there is no Z. So the first thing I'm going to do is I'm going to do row 1 and row 2 to eliminate my X. So when I do that, I am going to multiply row 1 by 3. So over here is going to be my workspace. So row 1, I'm going to multiply by 3 and get 3, -9, -3, 9, and then I'm going to add it to row 2, which is negative 3, negative 4, 2, negative 8, and when I add those, I get 0, which is good. That's what I wanted. Negative 13, negative 1, 1. So row 1 is untouched. Row 2 right now is going to be that 0, negative 13, negative 1, 1. And now what I'm going to do is I'm going to do row 1 and row 3 to eliminate the x. So 3 times row 1, I just wrote that, so I'm just going to copy that down. And now I'm going to do row 3, negative 3, 2, 0, negative 6. And when I do that, I get 0, negative 7, negative 3, and then 3. Then I'm probably going to do, not probably, I'm going to do row 2 and row 3 to eliminate the y. So when I do that, I'm going to multiply row 2 by a 7. So 7 times row 2. So 7, that'll be a 0, and then that'll be negative 91, negative 7, and then 7. And then I'm going to do 13 times row 3, so I'm going to do 0, positive 9, oh, I'm going to do negative 13. Um, 39 and negative 39. And when I do that, I'll have 0, 0, and then when I add those, I'll get 32. And when I add those two, I get negative 32. And so at this point, I'm going to find it helpful to divide by 32. And I'm going to have 0, 0, 1, negative 1. So right now what I have is I have 1, negative 3, negative 1, 3, 0, negative 13, negative 1, 1, 0, 0, 1, negative 1. At this point, I can continue to do reduced row echelon, or I can change it back to equation. So I'm going to show you the back substitution part. So if I had this x minus 3y minus z is equal to 3, that's the first equation. Then my second equation would be negative 13y minus z is equal to 1. And the last one I have z is equal to negative 1. Now I can do that back substitution. And I can go negative 13y minus z, which is a negative 1, is equal to 1. So negative 13y, and then the plus 1 is equal to 1. So negative 13y is equal to 0, y is equal to 0. And then for the last one, I'm substituting negative 1 for z and 0 for x. So I'm going to have, y, x minus 3 times 0 minus z, which is negative 1, is equal to 3. So this is going to be x plus 1 is equal to 3. So x is equal to 2. So my solution is 2, 0, negative 1. And I am done. Looking at the next one, number 22. I throw them in matrices all the time. So I'm just going to do 3, negative 2, 1, negative 6. Then there is no x, negative 4, negative 5, 2. Then x, y, z, negative 2. So if I'm following the pattern, the first thing it says I should do is row 1 and row 2 to eliminate the x. But the x is already gone. There's already a 0 there. So I'm not going to bother doing that first step because I'm happy with that 0 in that row and in that column. The next thing I'm going to do is row 1 and row 3. So row 1 and row 3 to eliminate the x. So I'm going to leave row 1 alone. 3, negative 2, 1, negative 6. And I'm going to leave row 3 alone because they're already opposites. And I'm just going to add what I have. And when I do that, I have 0, 2, 6, and then negative 8. So now, if I have 3, negative 2, 1, negative 6, 0, negative 4, negative 5, 2, and then 0, 2, 6, negative 8. Now the next thing it says is I should do row 2 and row 3 to eliminate my y. So I am going to multiply row 3 by a positive 2. So row 2 is going to stay the same. And 2 times row 3 will be 4, 12, and negative 16. So I'm going to have 0, 0, and then this will be 7. This will be negative 14. At this point here, I'm going to divide both sides by 7. I'm going to get 0, 0, 1, negative 2. And I'm going to keep on doing the whole reduced row echelon on this one. Just to see if we can do it. So this one's 0, 0, 1, negative 2. Then the next thing it says, if I'm following the pattern, is I should do 2 and 3 again, but this time I'm eliminating the z, so I'm eliminating this 5 right here. So what I'm going to do is I am going to multiply row 3 by 5, and I'm going to write that first. It doesn't really matter what order I write it in. And I set it and I wrote it backwards. So I'm going to take 5 times row 3. So I'm going to have 0, 0, 5, negative 10. And then row 2 is going to be 0, negative 4, negative 5, and 2. And when I do this, I'm going to get 0, 1, 0, and then divided by negative 4, this will be 2. So this will be a positive 2 in here. Almost made a mistake. Whoopsie. All right, so the next thing I'm going to do is I'm going to do row 1 and row 3 to eliminate the z. So that's what I'm looking at. So it looks like I'm going to multiply row 3 by negative 1. So when I do that, negative 1 times row 3 will be 0, 0, negative 1, positive 2. Row 1 is going to stay 3, negative 2, positive 1, negative 6. And when I do that, I'm going to get 3, negative 2, 0, negative 4. So I have 3, negative 2, 0, negative 4, 0, 1, 0, positive 2, 0, 0, 1, negative 2. Now the last thing I'm going to do, the very last step, is I am going to take row 2 and row 1 to eliminate that y. And when I do that, it looks like I'm going to multiply row 2 by a positive 2. That should do the trick. So 2 times row 2. So this will be 0, 2, 0. And then this will be a positive 4. And then row 1 is 3, negative 2, 0, negative 4. So this will be 3, 0, 0, 0. So dividing both sides by 3, it's going to be 1, 0, 0. And then 0 divided by anything is 0. So I am in complete reduced row echelon form. I'm going to have that. And so my answers are going to be 0, 2, and negative 2. So follow the directions. If it says you have to do reduced row echelon, you do it this way. If it just says solve the system using Gauss-Jordan elimination with back substitution, then you can do like we did in 21. Once you get one variable, just simply back substitute it into the remaining equations. Number 23 asks you to find the inverse. So find the inverse of a 2 by 2. I honestly think it's easier to just do by hand and not pick up your calculator. Remember to do the inverse. You're going to do the determinant. So you're going to do those loops. So you're going to take AD minus BC. So you take AD minus BC. You take the reciprocal of that. And then remember, if this matrix was ABCD, the A and the D switch places, and then the signs on B and C change. So if I'm doing this one, I'm going to have 0 minus 0, which is 0. So when I go to do the determinant, I'm going to have 1 over 0, and that's not possible, which means this is not invertible. Okay, let's do the next one, number 24. So I'm going to take negative 18 minus a negative 15. And when I do that, I get negative 3. So to find the inverse, I'm going to take 1 over negative 3. Now the 6 and the 3 change places, that negative 3. Then this positive 3 now becomes negative. This positive, negative 5 now becomes positive. Now I'm going to multiply by negative 1/3. I'm going to get negative 2, positive 1, negative 5/3, and positive 1. And that is my inverse. And if I called that A, that would be the inverse of A. Okay, this one, 25, find the inverse. You know, if I'm doing it in my calculator, I'm just simply going to raise it to the negative 1 power and call it a day. If it asks me to do it by hand, that's where I put the identity matrix next to it. 5, negative 2, negative 2. And then I try to make the left side look like the right side. So that's how I would do it. And I would do row 1 and row 3. But I'm just throwing this one in my calculator because I'm just going to say it's not clean. It's fractioning. It's negative 9 halves. And then this is 4, negative 17 halves, and negative 11 halves. But let's go ahead and do I have 26 on? Yeah, let's do 26 on it. I'm going to actually do 26 because I do have fractions in 26, but they're better fractions. So I only really want to do one. So let's just do this one. I am going to write this very, very neat. So negative 2, 1, negative 3, 0, 1, 0, 2, negative 1, 0. Then I'm putting the identity next to it. And I'm just going to draw a line. So now I'm going to do row 1 and row 2 to eliminate that x. Well, that x is already eliminated. So like I do 1 and 2 to eliminate the x. The x is already eliminated, so I don't have to do that step. I'm going to skip it. The next thing I'm going to do is 1 and 3 to eliminate that x. And I do have to eliminate that x, so I am going to do that. And I am going to write that work down here. So when I do that, we'll just go down here behind this one. I'm going to have negative 2, 1, negative 3, 1, 0, 0. Remember, you have to bring the entire row with you. 2, negative 1, 0, 0, 0, 1. And when I add these, I get 0, 0, negative 3, 1, 0, 1. So that's going to be my new row 3, which if I look at this, I have 2 zeros, which makes me happy because if I divide this by a negative 3, I'm going to get 0, 0, 1, negative 1/3, 0, negative 1/3. And so that's my bottom row done. 0, 0, 1. And then when we say negative 1/3, 0, negative 1/3. And so that's good. That row's good. And again, I'm trying to make the left side look like the identity. I have 2 zeros followed by 1. When I go to do the pattern, it says to do, after I do that, it says to do 1 and 2 to eliminate the z. Well, if I look here, that z is already eliminated. So this row is actually good. So these 2 rows are beautiful. They're great. I'm going to leave them the way they are. Now I'm going to finish off, and I'm going to do row 1 and row 3 to eliminate that z. So it looks like I'm going to multiply row 3 by a positive 3, which is good because that'll get rid of those fractions. So I'm going to do that over here. So I'm going to have row pencil. So 3 times row 3. 3 times row 3 is going to equal 0, 0, 3, negative 1, 0, negative 1. And then row 1 is going to be negative 2, 1, negative 3, 1, 0, 0. And when I add these, I'm going to have negative 2, 1, 0, 0, 0, negative 1. So I'm going to just write this matrix sheet down here. So I'm going to have negative 2, 1, 0, 0, 0, negative 1. Row 2 is that 0, 1, 0, 0, 1, 0. And row 3 is a 0, 0, 1, negative 1/3, 0, negative 1/3. So that's what I have right now. The next thing I have to do is I have to do row 1 and row 2 to eliminate the y. So it looks like I'm just going to multiply row 2 by negative 1. So negative 1 times row 2. And then I'm going to leave row 1 alone. So when I do this, I get negative 2, 0, 0, 0, negative 1, negative 1. But I want this to be a positive 1, so I'm going to divide by negative 2. So when I do that, I'm going to get 1, 0, 0, 0, positive 1/2, positive 1/2. So I'm going to write that. Once I have the left side looking like the identity, so once this looks like the identity, then this over here is my answer. To check it, I would go back up to the original one, raise it to the negative 1 power, and see if that's what I get from my inverse. Okay, number 27 says solve the linear equation using inverse matrices. On these, you're going to actually have to show us what you put in your calculator. So what we're going to want to see for that is we're going to want to see negative 2, negative 1, 3, x is 0, negative 1, 1, 2, negative 2, negative 4. I want to raise that to negative 1 power, and then I'm going to multiply it by my answers, which are 10, 0, and negative 22. I'm putting that in my calculator. You have to show me this, but that's it. You put that in your calculator, and you get your solution to be your x negative 2, 3, 3. So your x is negative 2, your y is 3, your z is 3. Make sure you're careful that this is x, this is y, and this is z. So this is my coefficients of x, my coefficients of y, my coefficients of z. These are my answers. All right, doing the next one, so I'm going to say, following this formula, I'm going to say x is equal to the inverse of a, so negative 2, 5, negative 1, 3, negative 1, 1. No x, 0, negative 4, z. Raise it to negative 1 times the answers, negative 13, 13, and 4. And when I do that on my calculator, I will get negative 4, negative 5, negative 4. All right, moving on to the next one, word problem. Love word problems. So the movie theater charges $12 for adults, $10 for seniors, and $8 for children. Children under 12 on Sunday afternoons. This past Sunday, the paid revenue was 1,972, 183 tickets sold. There were 16 more seniors than children. How many adults attended the play? All right, so here we go. Ready? I am going to say A is for adults, S is for seniors, C is for children. So my adults plus my seniors plus my children tell me how many tickets I sold, which is 183. I charged $12 for the adults, plus $10 for the seniors, plus 8 for the children, and my total revenue was 1,972. Then they tell me that there were 16 more seniors. So seniors minus my children, because there's more seniors than children, there are 16 more seniors. So when I subtract these two, I get 16. So those are going to be my three equations. I have to have three equations because I have three unknowns. It wants the adults, so it wants the A. So I am probably, you can do inverses. Okay, let's do inverses since we just did inverses. So 1, 1, 1, 12, 10, 8. I have no adults for this equation. 1, negative 1 children. Raise that to negative 1. 183, 1972, 16. When I put that in my calculator, and I do that, I am going to get the answer 103, 48, 32. It wants to know the number of adults. Well, remember, this is normally my X, my Y, and my Z, but in this case, it's going to be my adults, my seniors, and my children. So I am going to have 103 adults at this play. And you have to answer the question. Kramer's rule. So remember Kramer's rule again on your formula sheet. Kramer's rule. Please tell me you're on the sheet. Kramer's rule. So it says the determinant of A. I don't know if you know what that means, but this is what it means. So I'm going to find the determinant of 2, -3, 4, -3. I'm going to find that determinant. I can do it by hand. I can find it on my calculator. I don't know. I'm going to do it. And I'm just, well, I'm standing here, so I'm just going to do it. So I have -6 minus a -12. So that will be 6, yes? Yes. So that's my determinant. Everyone agree? Then to find my x's, I am going to find the determinant of putting the answers in the x column. So I'm going to do 11 and 7 here. The -3 and the -3 stay the same. Whatever answer I get, I'm going to divide by 6. And when I do this determinant, it's -33 minus a -21, I get -12 over 6, which ends up being a -2. Then to find the y, I'm going back up to this matrix, and I'm leaving the 2 and the 4 alone. Now I'm putting those answers of 11 and 7 into the y column, still dividing that determinant by 6. When I do that, I get a -30 over 6, which will be 5. So my answer is -2, 5. We're going to want to see the determinant of the coefficients, then what you put in for x, what you put in for y. So let's do the next one. We'll find the determinant of the coefficients first. I'm just going to go ahead and put that in my calculator, and when I do that, I get -2. And then when I go to find x, I'm going to say x. I'm going to put the -13 and -7 in for the x column, leave the y's alone, and divide that by -2. And when I do that, I get a +2 divided by -2, which is going to be -1. My y is going to be the 5 and the 3 are staying there. Now I'm putting the -13 and -7 in for the y column, still dividing by that -2. And I get 4 divided by -2, which is -2. So my answer is -1, -2. So then it says evaluate the determinant. This would be 5 minus 20, which would be -18. Oh my, bad math. 5 minus 20 is not -18, Mrs. Ward. It's -15. Just seeing if you were paying attention. Then I'm going to have 6 minus a negative, actually it's +8. So it's going to be a -2. 34, I'm going to do -3 minus 2x is equal to -3. Add 3 to both sides. I'm going to have -2x is equal to 0, which means x is equal to 0. The next one, I'm going to have -3x minus a -10 is equal to 13. So this is going to be +10. So -3x subtract 10 from both sides is 3. X is equal to -1. Use the determinant to find the area of a triangle. So I'm going to put the points. In order to find the determinant, it has to be a square matrices. So I'm going to fill the last column with 1s. And then I put a plus or minus 1/2 out in front, because the plus or minus tells me that my area of my triangle has to be positive. So when I put this in my calculator, I'm going to leave this plus or minus 1/2, and I put this in my calculator. Remember, it's that DET on my calculator. I am going to get a positive, no, I'm not. I'm going to get a -23. So I am going to make this 23 halves, or 11.5, and I'm just going to make it positive. That plus or minus just says, make it positive, please. Positive, please. Positive, please. All right. Next one, I'm going to do -1, 1, 3, -2, 6, 2, 1, 1, 1. Find the determinant of that, and then do plus or minus 1/2. So when I find the determinant of this, it ends up being a +25. So I'm just going to divide it by 2 and get 12.5. Again, it represents an area. It has to be positive. Okay, and that finishes up our stuff for matrices. So I'm going to stop there, and the last section will be for the conics and polar. Hope this helps, and see you next time in class.